Hey guys, here today with your homework review for yesterday's 11.2 probability worksheet. Um, Thank you to the 16 of you guys that filled this out so far. I do appreciate all the feedback you give me through this. Um, the responses 1 and 2 look pretty good, um, as does 3. Those are pretty good examples of something that could show up on a quiz. 4 is a geometric one. I'm going to go over that one um, in detail. 5 was generally okay. Um, and then 6 was a tough one. And 6 is kind of neat. It's different than anything that was on the notes, but I thought it was a neat one to put out there. I wanted to see what you guys could do with it. Here are our questions. So I already copied them. I'm going to paste them in. And let's go ahead and get started. Okay, and I just like to always put lines. All right, so let's start with number 4. Okay, so this is a geometric one. Which just means that you need to use some sort of geometry to solve this. Okay, in this one we're going to be dealing with some area here. So it says a pebble is dropped onto the board shown. If the radius of each blue circle is 1 centimeter, what is the probability that a pebble will land in a blue circle? And somebody had asked the question, are all the circles blue? And the answer is yes. I know it's kind of a weird color blue, but the way this one works is that it says each radius is 1. So right from here to here is 1, which makes sense, right? Because if this is 8 centimeters, then this entire thing is 2, right? So 2, 4, 6, 8. Okay, so the way geometric works, it's the same concept of probability. Is that you want um, the chance of it landing in what you want divided by um, the entire population, right? So how I usually approach these is, in order, if it's going to land somewhere on the board, we want to find the area of the entire board. So the area of, I'm going to call it the square because it is a square. And so that's just 8 times 8. So we get 64. And then if it's going to land in the blue circle, you need to find the area of the blue circles. So the area of one circle, it's pi r squared. So pi, radius is 1, squared, which just gives us pi. But there's 16 circles, right? So we have 1, 2, 3, 4 times 4, so 16. So area of 16 circles is 16 pi. Okay, so we're going to use this 64 and this 16 pi in our answer. So, excuse me, the probability that it lands in the blue circle would be the area of the 16 circles divided by the area of the entire thing. Right? So again, the area of the entire thing, so the total possibility um, is on the bottom. The bigger number is going to be on the bottom because if you put the bigger number on top, you're going to end up with something over 100%, which doesn't make sense for probability. Okay? And then the smaller number on top. So the smaller number is the circles because it fills up a lot of the board, but not quite the whole board, right? Because we still see some yellow in there. So we just do 16 pi divided by 64. As you can see from the answer key, I turned everything into percentage. So that gives us, it's going to be approximately 78.5%. And that's a pretty good geometric probability question, right? You're using geometry to figure out the area of each. And then once you do that, you're using the same concept of probability that you used in 1, 2, and 3. Okay? All right. Let's look at number 6. Now, I don't think there was an example of this note, but I wanted to put it on here because it's kind of a fun one, and it uses what we did yesterday, or I'm sorry, 2 days ago with permutations and combinations. So it says a lottery has 53 numbers, from which 5 are drawn at random. Each number can only be drawn once. What is the probability of your lottery ticket matching all 5 numbers in any order? Okay, so um, first thing I'm thinking is, well, I have to figure out how many total combinations are there. Let me say that again. How many total combinations are there from the 53 numbers of which 5 are drawn? Well, turns out um, this, right, we're already thinking it says each number can only, nah, that's not what I wanted. I think I wanted, oops, apologies, guys. I wanted to highlight this. Oh, any order. Well, order doesn't matter. Okay, so we need to find how many total possible combinations, right? So what are we choosing from? Order doesn't matter, so it's going to be a combination. How many total numbers are in the pool? 53. And how many of those 53 are getting picked? 5, right? So another way to think about it is we think back to combinations the other day. N is 53, R is 5. Okay, so if we use our formula, it would look like this. 53 factorial over 5 factorial times 53 minus 5 quantity factorial. Okay, we simplify that to 53 factorial over 5 factorial times 48 factorial. I did not need to put that in parentheses. And it's going to be a pretty big number, right? You can cancel out here, or you can just put in your calculator. This ends up being 2,869,685. Right? So that's how many possible combinations there are. So 2,869,685 possible combinations when you have 5 numbers drawn from a pool of 53 and they can end up in any order. So, what is the probability of your lottery ticket matching all 5 numbers? Well, if there's that many possible combinations, um, and you have one out of it. So the answer here is going to be 1 over 2,869,685. Right? It can only happen that one time. So if you turn this into a percentage, I can't remember which one I put in the answer key. It's going to be 0.00004 zeros, 3485%. And it's probably what I put in the answer key if I kept it in percentages. Okay. Again, that problem is probably a little more of a bonus type problem because because we just didn't really focus on that in the notes. But it is a neat problem because it includes the concept of combinations as well as just overall probability. All right, hope that was helpful, guys. Reach out if you still have questions on any of these or the ones I didn't go over. Thanks.